Now we'll configure here OSPF routing protocol. So we'll take 3 paths. Yes. So how it will be elected as the best path, we'll check here. So for that, we'll remove earlier configurations. So IP protocols. So RIP is working. So config terminal. No IP. No RIP. No router RIP. For this command, just will remove the RIP protocol. So IP protocols. No protocols were working. Now we'll same thing. Any protocols are working here, we'll check. Turn on. In this router, show IP protocols. Yes, RIP is working here. So for that, config no router RIP. Just I'm removing the RIP protocol. Show IP protocols. You can check now. No protocols are working. So same thing we'll do here also. Show IP protocols. So we'll remove RIP here also. No router RIP. Show IP protocols. No protocols are working. Show the protocols. No config terminal. No router RIP. And host name will change from ISP1. Just will use ISP1. So show IP protocols. No protocols are working. Same thing. Router RIP. And we'll change the whole path to ISP 1x1 router. Show IP protocols. So in this router, I think enable show IP protocols. No protocol, but show running configurations. Anyway, here default route we'll have used it. So I'll not use this router now for time being. So we have a 2 path. 1 and 2 will configure and will advertise the prefixes in between branch 1 to branch 2. So this is the MLS1 switch. So show the running configuration. We'll check before that. So what I did here, so we'll remove entire prefixes also here, IP routes. So that will be give us a so we'll remove the entire prefixes. No. So before that, no. Just copy and paste. And same thing here also will do. Show running configuration. Just copy and paste because time saving. Notepad, the notepad, just copy and paste. So no prefixes have. So you can check. Show IP route, whichever the local prefixes connected, those prefixes only we have here. And you can check in this router also. Show IP route, no prefixes. We advertised no routing protocols. Now we'll configure now OSPF. How we'll configure OSPF in between routers? We'll configure in this segment first. We'll check. So before that, we have to configure router ID. If our router ID is not configured, what will be happen? So whichever the loopback interface is there, first it will be check the manually configure router ID. How will configure router ID? Config terminal. Just to go to the config terminal, then config router OSPF, then give as a process ID, and after then just enter process ID. If mismatch also no issue, the establish the neighborship if process ID. But in EAGRP case, we have to configure same AS number, then only neighborship will be formed. Here no issue, the process ID. So what does that mean means if you are the one kind of client, so you have one process ID. So where will mostly the process ID concept is for ISP guys, internet service providers. So they what they will do for one customer part, they will give one process ID. And if one Wipro customer is there, one IBM customer is there, one different customers are there. So based on that customer IDs, customers, they will give one ID that is process ID. In this LAN case, no issue if process ID also mismatch. Now move to the router ID. Just it's any you have to give any router ID that will be IP address. Any IP address that will be format of IP address. Whichever you want to give, you can give. So here I am giving for this router 1.1.1.1. So that much only, no need to give subnet mask, only it will be 32 bit. So if here we manually configured router ID. So in this case, what we'll do, we'll configure any loopback interface as a loopback. So we'll configure loopback. So for MLS2 part, I am configuring interface loopback, that is 2, and IP router ID, IP address. Just give IP address 2.2.2.2 and subnet mask 255.255.255.0. So this is a, it will be elected as a route ID. So here I am not giving the router ID. So it will be elected. It is a router ID. If I am not configured anything, if I am not configured as a manually router ID, then it will be check the highest loopback interface. If loopback also is not there, whichever the interface having the highest physical IP, that will be elected as a router ID. So show IP interface. Here you can verify it. This is the loopback interface, where it is. This one is the loopback interface. So now move to the configuration of OSPF in between two routers. So first router OSPF, and then move to the give any router ID manually. Then how will advertise the prefixes? How will advertise the prefixes with network command? Network 13.1.1.0 and 255.255.255.0. Sorry, we have to mention a area ID. So area should be matched. So here I'm taking all the in area 0. All the routers are in area 0. We are not configuring multi-area. So we are configuring only area 0. So for this router, config terminal router OSPF and 10 process ID is 10 and network. If I'll not give any IP address router ID, then also neighborship will form 0, but 255 what it will be, how it will be elected as a router ID, we'll check. So incomplete area should be 0. So now I have advertised two prefixes only. Only one prefix that is in between. So neighborship is adjacency is formed. You can check here. Neighborship. So simple command. One is a router with OSPF process ID, then advertise the prefix whichever you need in between. This is the way we have to configure. Otherwise, one of the way also we have how will configure OSPF. OSPF configuration parts two ways to configure OSPF. One is likewise, otherwise we have another way. So config terminal and router OSPF 10. Just move to this interface. Before that, interface fast Ethernet 0 by 1 and IP OSPF. Likewise, also we can advertise. Then process ID and area is 0. Likewise, also we can advertise the interface as well as advertise the network ID. That prefix also. Two ways to we can configure. So here I am configuring again same thing. What I did. Interface fast Ethernet 0 by 0. This is ISP router and this one is for ISP 1 by 1. So for this interface, IP OSPF and process ID and area is 0. Just then OSPF will be found. See, we can check. So two ways to configure OSPF. One is with prefix. We have to advertise network command. Other one is with likewise. Two ways to configure OSPF. So this way I am not configuring. So just I am removing here. So with no command we can use no. So we can check show IP protocols. Only one neighbor we have So that is also established. It will be take 30 seconds. Dead timer is 30 seconds, as we discussed. Hello timer is for neighborship form once. Hello timer is 10 seconds and dead timer is 30 seconds. Once 30 seconds will be gone, then this prefix also will go. So we don't have it. So router OSPF 10 and network is 14.1.1.0 and 255.255.255.0. Area is 0. And for this router, exit and router OSPF 10 and network is 14.1.1.0 and 255.255.255.0 and area is 0. Now check here, neighborship will form in between ISP one router to ISP one by one. See, you can check here, neighborship is formed. So again, we'll configure here, config terminal, OSPF 10 and network is 15.1.1.0 and 0. Can give the here basically wildcard mask, but I am giving the subnet mask. Sorry for that. Even though the neighborship is formed, but what is wildcard mask? It is opposite to subnet mask. It is opposite to subnet mask. We have to give 255. So this is the bits are on and this bit is off. So what does it mean? Only one bit we are advertising, whichever last bit, area 0. So you can check here. I'll give the subnet mask network 15.1.1.0 and wildcard mask 0.0.255 and area is 0. Wait, neighborship will form. Neighborship is not for what happened. Show IP OSPF neighbor and see neighborship form. So see, actually we have three types of tables here. One is neighbor table and one is database table and one is this is a neighbor table and one is routing table. So IP route OSPF. In this routes, how many routes are available? That will be available in this. See here you can check. This is a metric value. This one is the AD value. Administrative distance value is 110 and this is the AD. Sorry, this one is the metric what we got from this router to this router. So this router to this router, only two we got AD value. So we'll change the entire network values. So no C. So what we discussed today for a neighborship form, both ends subnet should have to same. If different subnet, they won't form the neighborship. So again, what I am doing with network command 13.1.1.0 and this time I am advertising as a wildcard mask. So this is a class C value actually in wildcard mask. Area is 0. So subnet is different one. So this is a down state. It is showing this now neighbor also gone. So for this, I'm removing. No. Network 13.1.1.0 and I'm removing this prefix also. And I'm advertise with network command 13.1.1.0 and wildcard mask. This time I'm giving as a wildcard mask and area is 0 and one more prefix network 14.1.1.0 and wildcard mask 0.0.255 and area is 0. So this is neighborship form, but you can check 14 dot is not form because the different subnet gone down only. See, you can check here, not up, down, loading to down only. So we hard will remove this prefix, not this one, and 14 dot. We'll remove this one and we'll advertise with network wildcard mask 14.1.1.0 and wildcard mask 0.0.255 and area is 0. You can check now how many neighbors are there. So IP OSPF neighbor table. We are checking now neighbor table. Two neighbors. One is 2.2.2.2. This is the router ID. So what I did, loopback interface I have configured. That is the reason this router is elected as a router ID for that. So how will check? Show IP protocols. So see here you can check the router having router ID. This is a 15.1.1.1. So compared to 14, 15 is highest prefix. That is the reason it will be elected as a router ID is this one. So this is a 15.1.1.1. I have not configured router ID. So in this router, I have configured router ID. So now you can check show IP protocols. So see, this is the router ID elected directly. But in this router, what I did, router ID I have configured as a loopback interface, show IP protocols. So this is a interface is a loopback interface that will be elected as a router ID. So now you can check the routing table, show IP route OSPF. No routing, no routes we are getting till we have not advertised. Just we establish the neighborship. We establish the neighborship in between routers. In between routers, we have not advertised till LAN prefixes. So you here also you can check show IP protocols. We have not advertised any LAN prefixes till it. Got it? Do you have any questions? Understood what I did till?
Yes, sir. You have to establish a neighborhoods.
Oh, yes, I have established only neighbors with network command. Show IP OSPF neighbor. Just check the neighbor table. Yes, we got the neighbor table. Here also you can check two neighbors this router having. Show IP OSPF neighbor. This is a neighbor table and two neighbors we have. And show IP OSPF it. Show IP OSPF neighbor. So two neighbors, one is the 2.2.2. This is a branch router, and this one is the another router of this router. So this path only we configured. We'll configure in this path also later on. Once we configure entire thing, we'll check, we'll configure this path, and we'll check which path is the best path. So for that, now we'll advertise some prefixes, show IP route. So in routing table, check no prefixes we are getting through OSPF. We'll advertise this entire LAN prefixes through OSPF. Config terminal, interface. So for that, we have to go again router OSPF, and process ID is 10. And with the network command, we'll advertise the prefixes. So 192.168.10.0 and wildcard mask 0.0.0.255. So here we have this many LAN prefixes. So which area is 0. And one more prefix 192.168.20.0 and 40.0, 40.0 and 50.0. We have advertised the entire prefixes. So now you can check in this router MLS2. So earlier we haven't get any prefixes through OSPF. Now you can check. So IP OSPF. So IP route OSPF.
Do we need to advertise destination address also? Destination prefix.
No. Only what I did.
For this.
Here, whichever the LAN prefixes are there in connected, that connected interface is only I have advertised. No destination, right? Here, which destination I have advertised?
Yeah.
That prefix only in OSPF I have advertised with network command.
Okay.
Now you can check here. Show IP route. So IP OSPF neighbor. Sorry, I have not established neighbor in between. So neighborship is gone. So 13.1.config terminal. Router OSPF 10 and network 13.1.1.0 and wildcard was 0.0.0.255 and area is 0. IP OSPF neighbor. So IP OSPF neighbor. So running configuration. It's 13 dot only. Clear. IP OSPF process show IP OSPF neighbor. Why it is showing 14 here? Yes, this router having the highest prefix. That is the reason showing here that IP address. So I have confused till just show IP protocols. So see here the router ID is 14.1.1.1. So that is the reason here this router is showing neighbor is 14.1.1.1. Here it is showing that router ID. So address is 13.1.1.2. So directly connected interface IP address is here 13.1.1.1.2. So now you can check show IP route OSPF, and we haven't advertised anything the neighbor. So here we have directly connected. Now you can check here. So OSPF prefixes we are getting or not. Show IP route. So till we haven't get the prefixes. The reason behind, so something missed, we configured. Show running configuration, we'll check. So network is here also will advertise, later on we'll check. Config terminal, router OSPF 10 and network 192.168.60.0 and wildcard mask 0.0.0.255 and area is 0. And one more prefix 192.168.70.0 and no 80.0 again 90.0. We have advertised all the prefixes. Now you can check show IP route OSPF. So we are getting only one prefix 114.2. So we'll check show IP OSPF neighbor command. So one is my neighbor 15.1.1.1 and corrected interface is 15.1.1.1. Show IP route. Yes, now we have advertised through OSPF. We are getting only one prefix 14.1.1.1 through next interfaces. So clear IP OSPF process will clear IP OSPF process will clear entire thing. Clear IP OSPF process. Now you can check. Show the protocols. So IP protocols. So we have advertised this many prefixes in OSPF. Even though we are not getting the prefixes, we will try to ping now. Ping 192.168.20.10. Different VLAN, it's pinging. So we'll ping different location 10. So it is not reachable. What is the issue? Let me think. Show IP route. Show running configuration. We'll check any default routes are coming. So if default routes are so, the it will be issue will be happen. So actually, earlier our configuration was RIP protocol. So that is the reason this router behave like some uh, so behaving like these all are still protocol only, RIP protocol only configuration part. So some kind packet tracer will give some issues whenever we change the lab. So just reload it, then definitely it will be work. What I did earlier also, I process also I cleared, but it won't work. So here I did reload, then only it is working. Just I have reloaded. Once save the configuration, then reload it. Once you reload the entire all the routers, then it will be work definitely. So just I have reloaded. Thus, I haven't changed any configuration part. I have not changed any configuration. That same configuration only what we did, that only we have. But I have reloaded the routers. So earlier the RIP protocol was there. So that is the reason also some issue happened. Now you can check show IP OSPF neighbor. Only one neighbor we have, that is this router ISP1 router. That router having the router ID is 14.1.1.1, but that you can change. Interface is 13.1.1.1. So now check show IP route OSPF. This is our OSPF routing table. Now we are getting the prefixes of this LAN, entire LAN prefixes. I haven't changed any configuration. Just I have reloaded the routers, entire routers. So now you can check. This is the route AD value and path is 4. So what does it mean? Here 1 and metric is 1 and metric is 1 and metric is 1 for this router also. So 1, 1, 1, 1. So that is the reason we are getting the 4. So fast Ethernet, as we calculated, the metric, final metric is 1. That is the reason 1, 1, 1, 1. But here we are getting 3 only. 3 means this router. And 2 means this router. This router. So, but our final reach is our LAN prefixes, that is 192.168, 60.10, 70.10, and 90.1. This is our OSPF routing table. Now you can try to ping also. First, we'll try to ping the gateway. It will be reachable or not. We'll check later on our destination. Wait, it will be reached, but some packet drops will be happen. Wait. So here we are getting the prefixes, and here also we have to check. Show IP route OSPF routing table. So 10 dot prefix we are getting through. Next router is 15.1.1.1. This is the router. Before that, we'll ping any next hop 192.168.60.1. Yes, we can able to ping our gateway. And gateway to next hop ping 15.1.1.2. And 14 dot, we'll check next hop. Yes, we can able to reach. And we'll move to 13.1.1.2. Yes, we can able to reach. Now we'll ping 13.1.1.1. Yes, we can able to reach up to the MLS switch 1 and ping 192.168 10.1 gateway. Yes, we can able to reach this gateway and we can able to reach 10.10 the host PC. Will be find out the MAC address and then it will be pinged. See here. In this case also. So now we can able to reach. Reset 192.168.60.10. So first it will be reached to gateway to neighbor router. This is a neighbor router and this neighbor to this next hop interface and next hop interface. Apart from that, it will reach to destination. So don't worry, sometime packet tracer will be raised the issues because it's a big kind of lab only. So just wait for a while and then reload the routers, it will be work. And now you can check from our destination is here we are getting 4 routers. Once we configure this router, what will be happen? So for this, we have to start this router. Just I'll enable in between the OSPF. Now you can check. For first, I'll configure this router. I'll establish the neighborship in between these routers. So now best path is this one. Best path is this one. Earlier, once I'll configure in between neighborship, I'll establish in between second path. Then what will be happen? We'll check here. So for that, I have to advertise this prefix 16 dot this route prefix and 17 dot this prefix in these routers. So now you can check show IP OSPF neighbor. We have only one neighbor, that is this router. So what we'll do, we'll change, I will give some router ID for this router for understanding purpose. Config and we'll give this router as a some 6.6.6.6 router ID. OSPF router OSPF 10 and router ID is 6.6.6.6 and we'll advertise network now. Network 16.1.1.0 and wildcard mask 0.0.0.255 and area is 0 and one more prefix 17 network for this prefix. So second router, second prefix for this router also. Network 17.1.1.0 and wildcard mask 0.0.0.255 and area is 0. That much only. And this router and MLS1 configuration terminal interface, sorry, OSPF router OSPF 10 and network is 16.1.1.1.0 and wildcard mask 0.0.0.255 and area is 0. So straight profile, then they will form the establish the neighborships. You can check here loading to full. check show IP OSPF neighbor. So 6.6.6.6. This is the router ID of this router. Manually we configure. So for this router also we'll configure router config terminal router OSPF 10 and network ID 17.1.1.0 and 0.0.0.255 and area is 0. Wait for a while. Show IP OSPF neighbor. Not found. Just wait. So OSPF little bit late. So it is not convergence is not found like OSPF like EAGRP. EAGRP convergence is very fast, but OSPF convergence is slow compared to EAGRP. So two neighbors we found here. Now you can check through which interface, which path they are getting the prefixes, this LAN prefixes. Show IP OSPF neighbor. We check this command and show route OSPF. This is the path through we are getting 16.1.1.1. So this is the next hop IP interface. So now you can check three interface, three hops only. Metric is 3 now. Earlier we have a 4. Metric is 4. Now you can check here. The path is 13.1.1.1. Now you can assume this is a path. We are getting best path. This is the routing table and one more database table we have show IP OSPF database table. In this database table, this is the LSA1 and LSA2. We have two LSAs we are getting. This is the LSA1. This is a router LSA and this is a network LSA. Three types of tables in OSPF. One is neighbor table, one is database table, one is routing table. This is the database table. This one is the neighbor table. This one is the database table. Three tables in OSPF we have. Guys, any doubts? So we change the path manipulation also. We check the path, different path also. Path 2 and path 1. Finally, we are getting the LAN prefixes of MLS1, 2 router also, IP route. In this routing table, you can check the entire prefixes through OSPF we are getting. This is a AD value and this one is a metric. Through metric, you can verify it, which path we are getting, and this is a via interface. This is a via we are getting the interface. Understood? Any doubts?
చేసాలేం అర్థమైంది.
Good.
ఇది యూట్యూబ్ లో పెడతారు కదా?
Yes. I'll upload it.
ఓకే.